NASA just found a black hole wandering outside its galaxy, and it's eating a star. Something just happened hundreds of millions of light-years away that sounds almost impossible. Astronomers found a black hole not where a supermassive black hole is supposed to be. It wasn't sitting quietly at the center of its galaxy. It was far away from the galactic core. And then something even stranger happened. A star got too close. The black hole grabbed it with its enormous gravity and began tearing it apart. For a brief moment, an otherwise invisible black hole suddenly announced its existence by turning an entire star into a cosmic flare. But here's the part that makes this discovery so important. Scientists already knew black holes could destroy stars. What they didn't expect was to find a massive black hole doing it this far from the center of its galaxy. So, how did it get there? Was it thrown out? Was it left behind after another galaxy collided with this one? And if black holes can wander through galaxies like this, how many more are hiding in the darkness without us knowing? Because the black hole itself was invisible, but we only found it because it started eating a star, and that changes the story completely. To understand why this discovery is so strange, we first need to understand where astronomers normally expect to find supermassive black holes. Look at almost any large galaxy. At its center is an enormous concentration of stars, gas, dust, and gravity. And buried inside that central region is usually a supermassive black hole. These objects can contain millions or even billions of times the mass of our sun. Don't shine by themselves. You can't simply look into space and see a black hole sitting there. Instead, astronomers find them by watching what their gravity does to everything around them. Stars orbit them. Gas heats up as it falls inward. And sometimes, if a star gets dangerously close, something extraordinary happens. The black hole can tear the star apart. Scientists call this a tidal disruption event. Imagine holding a soft ball close to an incredibly powerful gravitational field. The side of the ball closest to the black hole feels a stronger gravitational pull than this side farther away. As the difference becomes extreme, the object stretches. For a star passing close enough to a black hole, that difference becomes catastrophic. The star is pulled apart. Its material gets stretched into streams. Some of that material can eventually fall toward the black hole. And as it does, it becomes extremely hot and produces an enormous burst of radiation. The black hole itself remains dark, but the destruction happening around it can become visible from hundreds of millions of light-years away. And that's exactly what happened here. The event was detected after a star passed too close to a black hole in a distant galaxy. But this wasn't happening at the galaxy's center. It was happening out in the outskirts. NASA describes it as an orphan black hole because the black hole appears to be separated from the normal environment where astronomers expect a supermassive black hole to live. And that immediately creates a problem. If supermassive black holes are usually anchored in the centers of galaxies, why was this one wandering so far away? The answer may be hidden in the violent history of galaxies themselves, because galaxies don't simply sit still. They collide, they merge, they pull each other apart through gravity, and when that happens, the black holes inside them can interact in ways that are incredibly complicated. Imagine two galaxies approaching each other over millions or billions of years. Their gravitational fields begin changing the orbits of stars. Gas clouds collide. Stars are thrown onto new trajectories, and the black holes at their centers can eventually become gravitationally connected. But sometimes, the final configuration may become much more complicated. Multiple black holes can interact, and under certain circumstances, one black hole can receive a gravitational kick that sends it away from the galactic center. It doesn't need to escape the entire galaxy. It can simply begin wandering through it, and that could be what we're seeing. But scientists have another possibility. Black hole may have once belonged to a smaller galaxy. Then that smaller galaxy could have merged with a much larger one. As the smaller system was gradually stripped apart, its stars and gas could have been dispersed, but its central black hole could survive. Eventually, almost everything surrounding it could become too faint to detect, leaving behind something bizarre, a massive black hole with almost nothing visible around it, a cosmic orphan. And this is where the discovery becomes much more than a strange black hole story, because astronomers have spent decades trying to understand something fundamental. How many massive black holes are actually wandering through galaxies? The problem is that most of them may be completely invisible. A black hole sitting alone in the darkness doesn't announce itself. It doesn't produce light simply because it exists. There may be no bright disk, no obvious jet, no giant cloud of glowing gas, nothing that tells us, I'm here, until a star makes the mistake of coming too close. And that's exactly why this discovery is so clever. The scientists weren't simply looking for wandering black holes. They were looking for the crime scene. They searched for stars that had been violently disrupted away from the centers of galaxies. In other words, instead of asking, where are the wandering black holes, They asked, where are the stars that have been destroyed by something that shouldn't be there? That strategy allowed astronomers to find an object that might otherwise have remained hidden, and suddenly, the destruction of one star became evidence for an entire population of invisible objects. The black hole involved is estimated to have a mass of around 1,000,000 suns. According to recent modeling, that makes it vastly more massive than an ordinary stellar black hole, and yet it is still much smaller than the enormous black holes that can sit at the centers of giant galaxies. This unusual combination is part of what makes the event scientifically valuable. Researchers can use the light from the shredded star to study the black hole that caused it. They can estimate its mass. They can study the radiation produced by the disrupted material, and they can compare its position with the center of its host galaxy. The more measurements they collect, the better they can reconstruct the black hole's history. But there is still something they don't know. How did it get there? One possibility is a gravitational kick. Imagine three massive black holes interacting in a crowded region. Their gravitational fields don't simply pull everything toward the center. The interaction can become chaotic. One black hole can lose energy, another can gain it. And in some scenarios, one object can be kicked away from the central region. It's like a cosmic gravitational slingshot. The black hole doesn't need an engine. It doesn't need fuel. Gravity itself can provide the kick. Another possibility is a galaxy merger. A smaller galaxy may have entered a much larger one. Its stars could have been stripped away. Its gas could have been scattered, but its central black hole might remain. Eventually, you could end up with a massive black hole moving through a much larger galaxy with almost no obvious visible companion. And if that's what happened here, this object could be a surviving remnant of an ancient galactic collision. Now think about the implications. If wandering black holes exist in significant numbers, the centers of galaxies aren't the only places where massive black holes live. There could be a hidden population spread throughout galaxies, but most would be almost impossible to see until they interact with something, a star, a gas cloud, another black hole, or perhaps something we haven't detected yet. And this is where the discovery connects to one of the biggest developments happening in astronomy right now. The Vera C. Rubin Observatory has officially begun its massive 10-year legacy survey of space and time. Its mission is to repeatedly scan huge portions of the sky and create an unprecedented movie of how the universe changes over time. And that matters because a tidal disruption event isn't permanent. It happens, it brightens, it changes, and then it fades. A telescope that repeatedly surveys the sky has a much better chance of catching these brief cosmic events. NASA says researchers plan to use Rubin's enormous survey to search for many more tidal disruption events, including ones occurring away from galaxy centers. That means this black hole might not be the end of the story. It could be the beginning of a search, and there's another telescope waiting in the wings. NASA's Nancy Grace Roman Space Telescope is designed to survey enormous regions of the sky with high sensitivity. Researchers expect Roman to extend the search for these events much farther into cosmic history. Together, observations from Swift, Rubin, Roman, Hubble, Webb, and ground-based observatories could eventually reveal how common wandering black holes really are. And that could answer a question astronomers have been asking for years. When galaxies collide, what happens to their black holes? Do they always remain in the center? Do some get kicked away? Do others remain hidden inside stripped-down remnants of smaller galaxies? Or are there millions of massive black holes wandering through the universe that we've simply never noticed? Right now, scientists don't know the full answer, but for the first time, they have a much better way to look. And here's what makes this story so strange. The black hole didn't suddenly appear. It was probably there for an incredibly long time, quiet and invisible, moving through the outskirts of its galaxy. Nobody watching from Earth would have known it existed. Then one ordinary star passed too, close, and that changed everything. The star was destroyed. Its material became incredibly hot. Radiation traveled across hundreds of millions of light-years, and eventually, that faint signal reached our telescopes. A signal that effectively said, there is a massive black hole. Here, not at the center, not where we expected, but out there, wandering the universe may be, filled with objects like this, objects that are completely invisible until something interacts with them. And that's one of the most important lessons from this discovery. Astronomy isn't always about seeing the object itself. Sometimes, it's about seeing what the object does. A star disappears, a burst of radiation appears, a galaxy center doesn't match the location of the event, and suddenly, scientists can reconstruct the presence of something that cannot be seen directly. This is cosmic detective work on an almost unimaginable scale. And now the search is getting bigger. Rubin is scanning the sky. Roman will eventually add another powerful view, and astronomers are developing better algorithms to identify these rare events automatically. The next wandering black hole may already be hiding in the data. We just haven't recognized it yet, so the next time you imagine a black hole, don't picture only the enormous dark object sitting quietly at the center of a galaxy. There may be others, moving through the darkness. Carrying the remnants of ancient cosmic collisions, invisible until a star crosses the wrong path. And when that happens, the universe may briefly light up around something that has been hiding for millions or billions of years. NASA didn't simply find a black hole. It found a way to hunt for the invisible dot. And if this new method works, as researchers hope, this single destroyed star could eventually become the first clue in a much larger census of wandering black holes across the universe. The black hole was hidden, the star, WASN, (T), and in the end, the star's destruction may be exactly what allowed humanity to finally see the monster that was waiting in the darkness. One wandering black hole, one destroyed star, and potentially an entire hidden population still waiting to be discovered. If you want more stories about the strangest discoveries happening at the edge of what humanity understands, subscribe and turn on notifications. And tell me in the comments, how many wandering black holes do you think could be hiding in the universe right now?